Okay, everyone. Hello. My name is Noel Rodolfo. I am presenting with my two teammates, Inju and Roshan, and we are presenting image in paint anything. Segment anything meets image in painting. And for this, we will be going over three different parts: an overview of the paper and the models that it has, a demo of this pipeline, and then also what we have. So for the overview part, we love the people who have oh. Oops, sorry. And the lovely people who have made this pipeline, they've created a visual for us to help us understand what's happening. Inpaint Anything is a pipeline that combines MetaSAM, which is segment anything, technology with state-of-the-art computer vision models to accomplish various tasks. As shown in the visual, these tasks include remove anything, fill anything, and replace anything. And as a brief overview of how these work, you can see in the top one, remove anything. The object that is segmented, the mask is removed, and then the background is kind of filled in to make it seem as if the object was never there. Fill anything. This takes it a step further. Instead of making it seem like an object was never there, and instead adds in a new object, which takes a lot of influence from the text that is passed in. And then replace anything. Instead of removing the object, everything around the object is removed. And then you, with the use of text, the background is then replaced. And let's move on to the next slide to discuss what the need for Inpaint Anything and the issues that it addresses. State-of-the-art image and painting models perform well, successfully in painting large regions with complex structures at a pretty decent resolution. However, these models require fine annotations for each mask, which can become a limiting factor. Additionally, in-painting models can only use context to fill in areas and cannot necessarily create new content. SAM is a powerful segmentation model and which produces high-quality masks, but its mask segmentation predictions have not been fully explored yet. So by combining SAM with state-of-the-art image and painters and AI-generated content models, Inpaint Anything aims to create a robust pipeline for solving more general image and painting related problems. And then, so to speak about the different models that make it up, SAM is a state-of-the-art PIT-based image segmentation model, which was recently released. It was trained on the SA1B dataset, which contains 11 million images and 1.1 billion masks. SAM has already demonstrated great functionality and works in tandem with the other models to perform tasks that I will discuss in more detail in the next two slides. Image in painting is a well-explored problem in computer vision. For those who may not know, image in painting involves using models to fill in missing or damaged parts of an image. For this pipeline, the use of Llama was explored. Llama works well with mask-based in painting and generating repetitive visual structures, which is part of the reason why I was chosen for this pipeline. It is used with SAM for the remove anything task. In this task, the user clicks on the object, SAM segments and removes the mask. And then after that, the hole is filled in using the context around the mask with Llama. The use of AIGC models, or otherwise known as AI-generated content models, attempts to address the issues that image in-painters have with generating new content. For this task, Inpaint Anything has chosen to use Stable Diffusion. This allows for the use of user-inputted tasks, giving the user control over the output and enabling the generation of new content. This is used with SAM for the Fill Anything and Replace Anything tasks. For Fill Anything, as previously mentioned, Fill Anything, it takes remove anything a step further, and this time it will take a text and then Stable Diffusion will then fill in that hole with a new object or new content. And for Replace Anything, it will take that mask, and then it will Stable Diffusion will again take in the text, and instead Replace Anything, it will just Stable Diffusion will generate the background around the image. And then now I will pass this on to my teammate Rajan.
Thank you, Nal. So for testing on the three pipelines, we tested a bunch of test cases, and let me share with you some of the notable ones. The remove anything pipeline focuses on the subject removal process. Using the segment anything model, it detects the subject in question and utilizes llama to paint the background image. We were able to successfully paint over the cat as well as the fox to create a seamless background. The fill anything pipeline allows users to fill any object in an image with any content that they want. Once the object is determined by SAM, it uses stable diffusion model to convert the text prompt into a filler for the detected object. For the TV, we aim to fill it with a painting, and similarly for the cat, we aim to fill it with a dog. The stable diffusion model stuck with the prompt and gave us these amazing results. The replace anything pipeline is the counterpart of fill anything pipeline. While fill anything focuses on replacing the selected object, replace anything focuses on changing the background of the object. Since the area to be replaced was more, the image generated was less accurate in general. For the first test case, the stable diffusion model was able to create a logical scenario where the empty environment of the stadium was replaced with a location in the mountains. However, it had difficulties generating accurately scaled trees for the baby elephant in the second test case. Fill anything and replace anything methods take around 30 minutes to generate the results. However, remove anything method is much faster, so it would be faster to just show that as a live demo. Here we have already populated the segmentation masks for the man in front of a bridge, and we are aiming to remove the man from the image. So once we click on the Inpaint image, it starts working on the model starts working, and it will be attempting to remove the man as seamlessly as possible. Even though this is a complicated background, the object itself is much smaller, and hence we were able to successfully remove the man from the scenario. Now let me hand over the presentation to Imju, who would explain what we learned.
Thank you, Rajan. So in this segment, we want to show the test results and then go in depth to learn about the possibilities and the limitation of this model. For remove anything task, it worked really well with the simple background. With the choice with this image that that has the pie on a simple plate, it removed the slice of pie successfully. The next, for complicated background, in this case, which we are using the picture with the slice of cake and a little bit of pattern in the plate. When the slice of cake was removed, we found that cake was removed, but the part of the plate that was behind the cake was not restored cleanly. Next. For fill anything task, this was a successful case. The big objects that is obvious in the picture, like this beer mug, was removed successfully to the coffee mug. As you can tell, it also generated the picture, the finger in the picture as well. Next. For next to fill anything task, we tried to change this guy in the lake to be a boulder, but the task failed in this case. So it only changed the guy's jacket color, but we were not able to replace it with the boulder. Next. For replace anything task, we tried with a simple text prompt. It worked well. So for this statue, the angel statue, there was the background was replaced with a water fountain, and it did the job correctly. Next. For next task for replace anything, we use some complicated text prompt. So we pick the picture in the wall and then put them in the live gallery as a prompt called at a crowded art gallery. So it was able to place the art in the wall, but the rest of the background was a bit distorted. So it was having some difficulty in creating the correct background as we expected. Next. So here are some recommended practices by the author. So dilation matters. There are some challenges with masking for complicated objects and background, like holes or discontinuous boundary. They decide to choose a large dilation for fill because of that. And also fidelity matters in this framework. Because most of the generative AI models use a fixed size of images, and some of the images need to be shrunk or needs to be cropped. So the decision to do the proper shrinking or cropping is important to avoid losing too much information. And last, the prompt matters. The type of prompt that you are giving to the stable diffusion is influencing the result. So if you want more elaborate work, then you definitely need to have multiple tries and the proven techniques to be learned to achieve the result that you want. Next. So here's our conclusion. In our testing, we learned that the pros of this approach was easy to use as claimed. The masking, because masking was done with just one click. And it's a reusable architecture. And we were able to implement with the working code, and the code is available in Colab. Cons of this approach is first, that it requires a computation resource pretty heavily because it needs two models at once for each task, SAM and the llama, or SAM and stable diffusion. So for us to generate the fill and replace anything task, it took over 30 minutes to generate the result. The limitations that we noticed were it was having challenges in removing the complex background. Sometimes shadow was not masked, and the mask area definitely affects the accuracy. And it was not able to achieve the final result with complex prompt. So that concludes our presentation. Our Colab links are available in here. And if you have any question, please ask. Okay. I don't see any question on the top chat area in the live. Okay, if there's no question, then we can wrap up the call. And please look for us if you have any questions or information you need. Okay. Yeah, we did not check the images in, but thank you for the information, Sushama. image then the similar feature is available with T2I. I don't know. What was the question? And another question is about the choosing the beer image. We haven't looked at the image in editor. But thank you for providing that information. But I think it's, we are combining these known techniques to be to a pipeline was a meaningful exercise. So I think that's where we find this paper has some value. Any more questions? And yeah, Imagen doesn't seem to have a replace feature. And this incorporated also the replacing background. From the glimpse of the demo of the Imagen, it is replacing the object mostly. So yeah. Okay. If there's no other question, then we can end the call here.
Thank you everyone for attending.
Okay.